Greetings. In this one, I will talk about this formula, which states that the net force is equal to mass times acceleration. And I'll talk about its connection to the other formula for the same thing. So again, another way to talk about net force, but in terms of the change of momentum over a period that is the change in time. So basically, how I can convert it into the other way of writing it out is by realizing that this is mass times acceleration. And acceleration in general, most simple terms, is the change in velocity over the change in time. And now I can kind of separate it out a little bit fractionally and algebraically to show why this actually means the change in momentum for the numerator. So F is still m times delta V, and delta V, well, that is the same like, let's say, V2 minus V1, where V2 is the final one, V1 is the initial one, and their difference is the change. And it's all over the change in t. And the basic idea here is basically I can distribute the m, and I can see m times V2 minus m times V1. So basically, by the way, momentum denoted as P, and it is equal to m times V. So now I see here clearly that there's mv here, there's another mv here with different v's, which basically says this is the momentum with v2 with the final speed, this is the momentum with v1, alright? So their difference make up the numerator as follows, and then of course I just rewrite the denominator again as delta t. So what this tells me is that this is basically the, again, momentum for the end speed, and this is the momentum for the beginning speed. So again, yet again, I can write it again this way, that this is actually equal to, let's say this is the final momentum and this is the initial momentum, where what momentum talks about is the product of the speed and the mass. So again, over the change in time. So the change in momentum, the final momentum minus the initial momentum over the change in time, is another way to talk about net force. And because I have P2 minus P1, I might as well also write it again as delta P. So this really nicely transfers quickly into the change in momentum over change in time. Alright, so let me basically think about what kind of net force that would be if the change in momentum was, let's say the change in momentum was supposed to be 20 kilograms meters times second to the minus 1, and the change in speed would be, let's say, 3 or maybe 5 seconds. In such case, what would be the net force in such a scenario? Well, I can calculate it very easily straight from this formula that I just derived. And what this formula says is basically net force is equal to the change in momentum over the change in time. And so again, I can even use this formula to further derive another one. Let's say net force times the change in time equals the change in momentum, talking about impulse, force times time, and so on. But I might do that as a separate topic in another one. But in this one, what I'm talking about is basically just applying this formula I just derived here. And the idea is now I'm supposed to find, let's say, the change in momentum, 20 kilograms times meters per second, and the change in time over that change in momentum process is 5 seconds. So if it takes me 5 seconds and the overall change in momentum is 20, then it's 20 over 5. And basically the idea is that the net force will be 4 newtons as follows. Alright, so this is a concrete example how one can apply this. And of course, one might be solving problems where, let's say, the force is known but the time is not known, and then it is just about reorganizing the equation and working with it more. But of course, already from this formula, a lot more stuff can be derived, which I will do in another one.